Hi, Mark here with My Engineering, and in today's video I'm going to be talking about using 3D scanning for flange inspections. Now, for the purpose of this video, just for clarification, I'm not only just talking about flanges, like this 3D printed one that we're going to be using in a little bit, that you'd see on standard piping, but this would also apply to using scanning for exchanger shells on either the shell side, the head side, or the bundle, or even on a vessel where you have different components of the shell that bolt together. Any sealing surface that you would have, like a gasket face, you can use 3D scanning to do a proper analysis on that surface. Now, there are several different types of scanners that would fall into the 3D scanning category. The first one that's most common out there would be like a LiDAR scanner. You set these up on a tripod. They capture an enormous amount of data, so like an entire room or a unit in a refinery, whatever you have. The difficulty with that is they are relatively inaccurate in terms of quality inspection. So you're going to be dealing with sub-centimeter, possibly plus or minus a couple of millimeters. Rarely do you get sub-millimeter, and that's just not good enough for quality inspection. The next best technology out there, which is very common as well, would be structured light. So a very good example of this would be like the Artec Leo. Fantastic scanner. I love the Leo. It's really good. A lot of service companies may use them already for leak sealing, where you could scan a valve or a piece of piping that you need to enclose. So you take the scan, you can reverse engineer an enclosure that will box that in. Unfortunately, the maximum accuracy of the Artec Leo is at about 0.1 of a millimeter, which is about 5/1000 of an inch, and that's just not going to meet ASME standards for flanges. So we have to go a little bit tighter, and that brings us into the world of blue light lasers. You may be familiar with these already. They typically require little targets, little reflective stickers in order to track where they are in space. But the advantage of these is the accuracy that can be achieved. So the accuracy of the Scantech, now called Scanology scanners that we carry, can be up to 0.8 of a thou, so you're at 0.02 of a millimeter, incredibly accurate. And they can also be incredibly fast with the way they capture the data. So now I'm going to jump directly into the scanner that we actually recommend for doing these flange inspections, and that is going to be the Scanology KScan X. So this is one of the latest scanners released by Scanology, formerly known as Scantech. And it is a blue light laser scanner. It is incredibly good at capturing scenes from very close, all the way up to about 8 feet. So you get a huge area captured very quickly. The advantages of this scanner over other blue light laser scanners, number one is going to be your speed. It can capture up to 6.45 million points per second. So that's an insane amount of data. And it does that wirelessly. So now we don't need to have that tethered to a laptop right next to us. It has these two little Wi-Fi dongles, one on either side, that work with the Wi-Fi router that you can have sitting in your truck or somewhere off to the side. You don't need to have everything set up right where you're located on if you're in a facility or in a work site that's not really great for laptops. As long as it's kind of nearby with a Wi-Fi connection, you're good to go. And so being completely wireless, of course, it also needs to have a power source, which it has on board. You put into lithium-ion batteries. They are hot swappable, and so it is all internal. We don't have to have an external battery pack that we wear on our belt or something like that. This is it. This is everything you need. And the third nice little piece of this is it has a phone mount on the back. So we can attach either an Apple or an Android phone so that you can actually watch what's going on the screen on your laptop and have some two-way communication with your laptop just by looking at your phone. So now you are no longer tied to your laptop and scanning your flange over here. Everything is right in front of you where you want it to be. And the last thing that is very nice about this scanner is it comes with these nice scale bars. So this will reduce your volumetric accuracy down to 0.01 of a mil, so over a long distance, if you're doing a large flange, let's say an exchanger that's 6 foot diameter, you don't have a lot of volumetric drift over the whole course of the model. So your overall, you're actually going to be very much more accurate than you may be with other scanners without these kinds of scale bars. Now, this wouldn't be a very fun video if I didn't also get to show you a few lasers. So I'm going to show that to you right now. We're going to scan this little flange. Just to show you this, now am screen mirroring so you can see me on my own phone being mirrored from my screen. So everything that's going on the computer, I am watching right here, which means I don't have to, I can turn the computer screen around and not have to look at that at all. And what we're going to do is we're going to scan this little 3D printed flange and show you exactly how quick it is. So keep in mind that while I'm scanning this, how long it would take to mount an ID mounted machine here with a dial indicator, get that all zeroed. From everyone that we've been talking to, that can take up to an hour, sometimes a little bit less, sometimes a little bit more, depending on how finicky the flange is being and the operator who's actually doing it. And we're going to be able to capture this whole thing in, it's going to seem like seconds. So I'm going to share my screen with you now. So we are looking at DefineSight, which is the native scanning software for this scanner. And all we have to do to start our new scan is hit the play button on the scanner itself. And that will get us to scanning in all our little marker targets. So once we have those, we'll hit our mode button. And now we're in laser scanning mode. And basically all you have to do is just paint the object with the laser scanning. You can see it all fill in. And we got enough coverage there. I'm going to hit end scan. And you can see in a matter of seconds, we captured 390,000 data points. Granted, some of that is going to be my hand, but we can just imagine that there is well more than enough data to actually pull some useful measurements from. Especially when you're comparing it to using a dial indicator on the sealing surface, which you might get 8, 12, 16 clock points worth of data. This is going to give you a lot more data to work from. So the last thing that we just need to do is wrap that data, which takes it from the raw form that it's in right now into a mesh file, an STL, if you will, that we can export and bring it into our Flange Vision software. And Flange Vision, I'm going to leave in its own video, so we can update that video as the new versions come out. But essentially, the data collection part in the field is just a matter of seconds when you use a scanner like this, and it is going to be still incredibly accurate. You're looking at, right now with this scanner in this configuration, at about 1.2 thousandths of an inch. So you're at 0.03 of a mil with each one of these meshed at 648,000 polygons. Now, just to take this one step further, because I was talking about the versatility of this scanner, how you can scan really far away from certain objects if you want to capture a large, let's say it's an exchanger, a car, whatever you might have that's quite big, and you want to capture it quickly. You do it in a slightly lower resolution, but you can do it from quite a bit further away. And I'm going to show you here. I'm standing about 7 feet away from this object. I'm going to capture all the targets. So this is on the bay door here in our shop. And again, I'm standing approximately 7 feet away from the door itself. And if I zoom out, you can kind of see a little bit better. So we're capturing huge amounts of data very, very quickly. So I'm going to leave it there. I try to cram as much information as I can while still trying to keep these videos under about 10 minutes. I think I'm going to be very close on this one, so we'll see how that goes. If you wanted to have any more information or clarification, or if you wanted a demonstration on this scanner and how it would work for you, you can always reach out to us, support@myeng.ca, or you can just leave a comment in the comment section below. Don't forget to tune in to the Flange Vision, which is kind of part 2 of this video. That would take the mesh file that we just created and produce an actual inspection report. We're very proud of that one. It's a solution that we've developed in-house because we found that there was a gap in the industry on actually making these reports with 3D data. If you like watching these videos from My Engineering, don't forget to like and subscribe so you can get all the new ones as they come out. Thank you for watching, and we'll see you in the next one.